Hey there, classes. Welcome back. If you check out the board behind me, we're using a little bit of this story, this book right here, this true story, Boys in the Boat, to use it as a vehicle for talking about microorganisms, to talk about exercise physiology. One of the things I love about trying to incorporate a story, again, we're not going too deeply into it, but we are using it because you remember things better when it's attached to a narrative, when it's attached to a story. I also like to kind of point out a couple of things. It's a great movie, but of course they had to compact a few things to get it into a movie format. For example, Joe Rance right here, depicted right here, and Joy Simdars, they knew each other very well before they went to the University of Washington together. As a matter of fact, it shows in the movie them sort of meeting or reacquainting at the college, but it turns out they knew themselves, they knew each other very well. And when we go into the brain pop that we started our day with, I just want to point out, we're talking a tiny bit about the Great Depression. And again, this is a biology class. We're focusing, of course, on the science. But it's one thing to just have a bunch of things that you memorize about the cell parts and about the science of what we're learning. It's another thing to see really how it fits in historically to some kind of context here. This was taking place at a time in America known as the Great Depression. Not great if you were living through it, of course. And the character of Joe Rance, a real person, look up Joe Rance for yourself. Again, he is the protagonist of this book, while the entire crew is. He is the person upon which the book focuses. I want you to imagine for just a second. He had lost his mom before he was 5 years old. His father remarried. He has 4 siblings, some step-siblings, but there's 5 kids living in a house in Sequim, Washington. He comes home at 15 years old one day, 15 years old from school. He's a good student, and they've got the car all packed up. The Great Depression has hit really hard, and he says, well, sorry, son, we're leaving. He's like, well, where are we going? He says, well, we're going to try and make it because we've got the kids to feed. There's no work here. There's no way we can keep going here at this house. But the thing is, Joe, you're not going with us. So at 15 years old, he was left alone in a house in Washington. He continued with school. He was a good student, and he was able to get by with some help from some neighbors and through a lot of gumption, working for himself. But when you look at his situation, again, take some time to read it if you get the chance. If not, look him up on Wikipedia. Truly an amazing person. But this is him depicted in the movie, him and Joy Simdars. They would end up married and living in Washington State. As a matter of fact, he ended up being an engineer, as a matter of fact, to jump ahead to the end of the story. But let's go into our notes today and how it relates to this. We're not watching the whole movie, but I am using some selective parts of it. So I'm going to turn off this that's behind me. And if you look at where we started today, again, keep in mind we're doing the biology, we're doing soil, bacteria, things like that. But we start with the Depression. We did watch the brain pop on the Great Depression. Everyone likes to kind of conflate or put together the stock market crash of October 29 with the Great Depression. Certainly, that is often seen by history as the kicking off point to the Great Depression. But the bigger thing that caused the Great Depression was a crisis in credit, a crisis in banks. And this will, again, tie into the biology in just a little bit. So hang with me here for just a second. But with some of the class today, we were talking about if you've ever had a credit card. Now, if you have a credit card and you go in, not a debit card where it takes money directly from some account that you've built up, but a credit card is basically saying, hey, I don't have the money for that Starbucks latte and sandwich right now, but my credit card company, they'll give you the money right now. And if I swipe this through, I promise to pay them back later. As a matter of fact, especially if you build up a debt, you can pay it back with interest later. What happens when you buy a house? You end up having not too many people are walking around with $1 million here in California to go buy themselves a house in their pocket and say, hey, here's $1 million, I'll take the house. Instead, you go to a bank, you go to a loan, you go get a loan, and the bank essentially owns the house. I'm simplifying, wildly oversimplifying here, but the bank essentially owns the house, and you pay them back every single month to live there, paying down your debt. And obviously paying interest. That's how the banks make money. You got to realize in the 1930s, there was a lot of people buying things with credit. There was no insurance on the banks back in those days. And when banks folded, when a bank went under, somebody might have gone and said, hey, I've got $10,000 in this bank. I would like to withdraw it now, please. sorry, the bank is closed. We don't have your money. You can imagine then, of course, the banks start to fail across America. It led to a cascade of no credit, no money flowing, unemployment. On top of that, now let's get into the biology, we talk a tiny bit about the Dust Bowl days. If you look at the Dust Bowl that's up here, we saw earlier in the year the difference between soil and dirt. Remember good old Mark Watney stuck on Mars? He had to take the dirt that was on Mars, turn it into some type of soil so he could grow potatoes. And to do that, he ended up taking some bacteria in the form of the waste that they had left there, essentially the bathroom on the space station. Using that waste, mixing it with the dirt, creating a soil. Remember, soil is a real living thing, if you will. Not one living thing, but it's a community of organisms, of microorganisms that we're going to go over here and see on the other slide. Hopefully you learned about in outdoor ed. We'll review that in just a second. An extra thing, as if there wasn't enough going wrong already economically in the 1930s, you've got an extended drought and very poor farming practices across the center of the country in particular, the Midwest. Farmers would plow fields again and again, year after year, not letting them recover, not letting them lay what we call fallow, and you've got the soil losing their microorganisms. Finally, you couple that with a drought and some huge windstorms. The wind kicked up these giant dust storms. Reporter said it looked like a dust bowl. If you remember, and I'm pointing to the window across the room here, a couple of years ago, you might have seen the skies all red in this area from the fires that were burning up in the wine country up in Napa County. We'll be talking about wine later on this week, and how you make it, how yeast make it. Well, if you can imagine the skies being red like that across the whole eastern United States, that's how people in New York, Chicago, Philadelphia woke up and saw tons of earth from the Midwest being carried by dust storms out to the east. And so again, lots of tie-ins here from what we've learned in class so far, a little bit of the social history, but again, we're focusing on the biology. Last little thing I wanted to point out, move my chair here, try and look back on your notes and check out what we learned was going on in physics back in the 1930s. Remember, this is when they're trying to get together atomic theory. They're looking at uranium. You might remember Twisting the Dragon's Tail by Richard Muller. We watched part 1 and 2 of that. And when they're talking about what's going on in the 1930s, this takes place against the backdrop of a world that's headed, unfortunately, tragically, towards World War II. So there's a lot going on here. Going on to the next pile of notes that we have over here. And again, I'll try and go through this as well with the other program that I've been using lately where I can highlight them and go into more detail. But if you went to outdoor ed, you might remember the good old FBI song, fungus, bacteria, and invertebrates. They're on the job. Whenever something dies, they have the FBI song going. I won't torture you and break out my guitar and sing it right now. But that was the one that the outdoor ed leaders were talking about in terms of what recycles, puts nutrients back into the soil. The fungus, we're starting with bacteria because, let me reach over here and grab this on our handout, our coloring handout the other day. Bacteria are the smallest living things on this handout. Notice there is something smaller on there, the viruses. We'll talk about them in detail later, but remember, viruses are not alive in and of themselves. Bacteria is the first thing that's alive on here. Things generally get bigger as you go on through, but bacteria is the smallest living thing on this right here. And when you're looking at bacteria, we're looking at one of the critical living things that helps make soil. Bacteria generally come in 3 shapes, although there's thousands of shapes out there, but they're generally in 3 main categories. Rod-shaped bacilli. If you've ever had, for example, strep throat, you've had Streptococcus bacilli. It's a rod-shaped bacteria that decided to take up residence in your throat. When we talk about fungus in more detail later, we're going to talk about how an extract from a fungus helps get rid of this type of bacteria if you have an infection. You've probably heard about penicillin. Of course, we'll go into that heavily later. Spherical bacteria and spiral-shaped bacteria. Again, 3 general shapes, but you can imagine, especially with the billions of bacteria that live on and in us, there are wildly different shapes, but these are the 3 main categories of shapes. When we checked out a little bit here on the boys in the boat. And again, this is our end of the day today, about 10-15 minutes with the movie. We're checking out the exercise physiology part. Coach Ulbrichson, again, real people, so please do look them up. Coach Al Ulbrichson, University of Washington, is giving the boys a lecture. He's talking about how much oxygen a normal person can take in and out, and how they're training so that they can use more oxygen. And almost couldn't ask for a better tie-in with the class, the first period class that was in here this morning. The PE teachers are out there right now torturing the kids with sprints. And by torturing, I'm just kidding, of course, but they're actually doing sprints out there right now, just outside my classroom. And you know that feeling when you're breathing so hard after a sprint that you're trying to catch your breath? Well, the tie-in with the debt thing that we did at the beginning, you are using right now as you're sitting, assuming you're sitting and watching this and not exercising while you're watching this, you're breathing in and out about 4 liters, maybe a little bit less than that, of oxygen per minute. When you're using more oxygen, you're expending more energy than your body can supply with the oxygen that you're breathing in, you're essentially going into debt. It's like overbuying on your credit card. It has to be paid back later. No one can keep sprinting nonstop around the track out there. And so the PE coaches right now giving everyone little rests. They're doing a series of sprints out there today. And you see the students in between the sprinting, huffing and puffing. They're paying back that oxygen debt. Remember, we're taking in oxygen. We're using that oxygen to make ATPs in the mitochondria through the process of glycolysis. And making ATPs is very efficient. We make ATPs in the mitochondria. The ATPs are like the energy currency of the cell. It's how it gets everything done. It's how it gets things into and out of the cell, because that takes energy for the most part. It's how it makes the proteins. That's the main thing that cells do, is they're protein factories. It's how they reproduce. They need energy to reproduce, to copy the DNA. All of those things take energy. ATP is how they get their energy. They make it by, and I can use the old air quotes, they make it by burning oxygen. When there's not enough oxygen available, we go into a different process that's not as efficient. It goes into oxygen debt. You have to kind of pay that back later. And as we move forward and we check out how microorganisms do their thing, we're going to learn a little bit about fermentation and lactic acid buildup, and the way you get ATPs when there's no oxygen available. Okay, that was a very quick overview. I'll try and go through the notes also online by highlighting some things, but I hope you're enjoying the little clips that we're watching from the boys in the boat. Again, I was trying to tout this book earlier in the year. It's a great read if you get the chance. Take care. See you online. Bye-bye.